Imagine two people separated by oceans, finishing each other's sentences, as if a hidden thread tied their minds together. Imagine two qubits, light years apart, whose measured states mirror one another instantly, no signal sent, no handshakes, just a stubborn, undeniable correlation. That stubbornness is quantum entanglement, nature's refusal to be classical. Tonight we use entanglement as both literal science and bold metaphor to rethink identity, leadership, and how AI can help us map connections beyond our immediate sight. This is for leaders who want to be vanguard alchemists, to transmute scattered information into cohesive, ethical, and sustained influence. What if your consciousness isn't confined to your physical body, but extends far beyond its perceived limits? Imagine two tiny particles, separated by vast distances, even light years apart, yet they instantly influence each other's state, no matter the immense distance between them. This phenomenon challenges our most fundamental assumptions about reality. This isn't merely a concept from science fiction. It's a verified principle of quantum mechanics known as quantum entanglement. It profoundly shatters our conventional understanding of reality, causality, and even our own individual identity. Prepare to have your mind expanded and your perceptions of the universe irrevocably altered. Quantum entanglement occurs when parts of a physical system become so deeply correlated that their joint description cannot be factorized into independent parts. Measure one, and you immediately constrain the other, even across distance. Einstein called it spooky action at a distance, his challenge with Podolsky and Rosen forced physicists to question whether the world is local and deterministic. Later, John Bell offered an inequality that turned philosophy into experiment. When physicists violated Bell's inequality, the old comforting picture of separable, local objects collapsed. Entanglement is not just a laboratory curiosity, it is the structural grammar of quantum reality. This is where art and literature can help our intuition. Voorhees' labyrinths, Woolf's streams of consciousness, and the polyphony of Rilke's letters all gesture toward non-local patterns, different voices, distant images, uncanny echoes. Entanglement, like good literature, forces us to read relationships, not isolated facts. This isn't merely a concept from science fiction. It's a verified principle of quantum mechanics known as quantum entanglement. It profoundly shatters our conventional understanding of reality, causality, and even our own individual identity. Prepare to have your mind expanded and your perceptions of the universe irrevocably altered. Could the universe be far more interconnected than we have ever dared to dream, with invisible threads and unseen forces linking everything, every particle, every being, everywhere, all at once, in a cosmic dance of interconnectedness? This profound idea suggests a unity far beyond our everyday experience. Entanglement fuels quantum computing, underwrites quantum cryptography, and enables sensors of extraordinary sensitivity. In quantum computers, entangled qubits perform computations in a joint, non-separable space that classical bits cannot access. In cryptography, entanglement allows protocols where any eavesdropper's presence is detectable, a new trust architecture. In sensing, entangled states improve precision beyond classical limits. But the practical impact is also conceptual. Entanglement asks leaders to track relationships and second-order effects. Much like a networked organization whose outputs depend less on single experts and more on distributed interactions, our strategic thinking must become non-local, mapping entanglements between teams, data, social goals, and ethical constraints. Have you ever experienced an undeniable, almost telepathic connection to someone, even when they are physically far away, perhaps across continents or oceans? What if that profound feeling is not just an emotional bond, but a subtle whisper from a deeper, more fundamental reality, hinting at an underlying quantum connection? Entanglement drags us into foundational questions. When does potential become actual? The quantum state describes probabilities, measurement picks an outcome. The so-called collapse, whether ontic or epistemic, remains debated. Interpretations proliferate: Copenhagen, many worlds; cubism, objective collapse models. Each has different implications for whether observation is passive or generative. For leaders, the analogy is clear. Observation, the act of attention, alters the system. The way we measure performance, the KPIs we choose, the surveillance we embed into teams, these choices change behavior and identity. If entanglement teaches anything, it's that measurement is not neutral. The vanguard alchemist must choose metrics that preserve dignity, nurture creativity, and avoid corrosive incentives. Imagine a thought experiment. Two coins are flipped simultaneously, miles apart, perhaps even on different planets. Yet, every single time, they always land on the exact same side instantly. This seemingly impossible correlation offers a simplified, yet powerful, glimpse into the perplexing nature of quantum entanglement. Here's where AIQ joins physics. Machine learning models, especially those built on graph-based and representation learning, excel at detecting patterns of correlation and higher-order structure. AI does not see entanglement in the quantum sense, but it models relational structure across modalities, social networks, multimodal sensor streams, and emergent cultural signals. With generative models, we can simulate counterfactual network dynamics and test interventions before applying them. Quantum-inspired algorithms, tensor networks, variational circuits, and hybrid quantum classical workflows are becoming tools in the AI toolbox. Practical idea: use AI to build a relational map of your organization, a living power matrix that combines SSQ, social and sustainable judgment, EEQ, emotionally ethical intelligence, and AIQ, practical AI fluency. Let AI surface the hidden entanglements, overlooked influences, ethical friction points, and fragile feedback loops. Then use human judgment to translate those signals into ritual, policy, and design. Imagine a thought experiment. Two coins are flipped simultaneously, miles apart, perhaps even on different planets. Yet, every single time, they always land on the exact same side instantly. This seemingly impossible correlation offers a simplified, yet powerful, glimpse into the perplexing nature of quantum entanglement. The renowned physicist Albert Einstein famously dismissed this phenomenon, labeling it spooky action at a distance due to its apparent violation of classical physics. However, a series of groundbreaking experiments conducted decades later conclusively proved his initial skepticism wrong, confirming the reality of entanglement. The power matrix is our practical instrument. Place 3 axes, AIQ, EEQ, SSQ, and plot initiatives, teams, risks, and opportunities. Entanglement appears where axes intersect. For example, a product launched with high AIQ but low EEQ risks amplifying bias and eroding trust. Entanglement, technical capability entangled with social harm. A mentorship program high in EEQ and SSQ, but low in AIQ misses scale and measurable impact. Entanglement, relational depth without systemic leverage. Use the matrix to design interventions that respect non-local effects. Rituals, heroes journal micro-practices, architectural changes, guardrails in data pipelines, and narrative framings that rewire incentives. The vanguard alchemist does not treat problems as atomized. She traces ropes between nodes, notices how tugging one knot shifts distant structures, and curates interventions that respect entanglement. At its core, entanglement describes a peculiar quantum state where two or more particles become inextricably linked. In this state, the measurement of a property of one particle instantly and predictably influences the corresponding property of the others, regardless of the vast spatial separation between them. If reality is deeply relational, personal identity is less a bounded island and more a web of reciprocities. This has moral consequences. Our decisions ripple. Our technologies inherit social imprints. Our identities are co-created. The ethical leader therefore cultivates three capacities: relational humility, accept that your view is partial and that your actions participate in wider dynamics; other orientation, practice co-regulation, listen, mirror, and craft spaces for mutual repair; anticipatory care, use AIQ to model future harm, and SSQ to weigh long-term societal consequences. This triad is the moral grammar for entangled leadership. The EPR paradox, a famous thought experiment proposed by Einstein, Podolsky, and Rosen in 1935, was designed to challenge the fundamental concepts of locality and realism within quantum mechanics. They argued that entanglement implied either faster-than-light communication or an incomplete quantum theory. Science explains, art makes felt. Use poetry, film and staging to teach entanglement. Gilles Deleuze's rhizomes, Toni Morrison's intergenerational voices, and cinematic cross-cutting, think Tarkovsky or Wong Kar-wai, are pedagogical tools. Design studio pilots where learners inhabit roles across time: a grandmother, a data engineer, a city planner, and trace how one decision cascades through other lives. Combine heroes' journal rituals with AI-assisted scenario builders so students see how non-local effects unfold. Pedagogy becomes practice: short, assessed micropilots where students map entanglement, propose ethical guardrails, and test interventions in simulated environments. This is Euno Praxis in action: ritual, assessment, and rapid evaluation woven together. Then came John Bell's groundbreaking theorem in the 1960s, which provided a concrete, experimentally verifiable way to test these challenges. Bell's inequalities, when violated, would definitively prove the non-local nature of quantum mechanics, ultimately shattering the foundations of classical physics and our intuitive understanding of reality. Relational audit, week-long sprint, use simple surveys plus network analytics to map entanglements in a team, present a power matrix, and 3 prioritized leverage moves. Entanglement Simulation Lab. Run a hybrid AI-human simulation of a product released to surface second-order effects. Require an EEQ mitigation plan. Heroes Journal Micropractice. Daily 5-minute reflection. Note one hidden connection you observed. Name its ethical stake. Record one small corrective action. These are short, evidence-focused, and scalable. They produce artifacts for CPD and institutional uptake. Subsequent experiments, based on Bell's theorem, unequivocally confirmed the reality of entanglement. These rigorous scientific tests provided irrefutable evidence that quantum connections are indeed real, operating in ways that defy our classical expectations and opening new avenues of scientific inquiry. Some thinkers argue that the measurement problem hints at consciousness's role. Others find that path metaphysically perilous. As a vanguard alchemist, avoid metaphysical dogmatism. The salient point is methodological humility. Whether consciousness is fundamental or emergent, we must treat intentionality as powerful. Our attention, measurements, and stories shape possibilities. Use the science responsibly. Use the metaphors ethically. Crucially, it's important to understand that entanglement does not, in any way, allow for faster-than-light communication. This means that the cosmic speed limit, the speed of light, remains inviolable, preserving one of the most fundamental tenets of modern physics. No actual information is transferred instantly between entangled particles. Instead, the profound correlation between them is only revealed upon the act of measurement. It's the shared destiny, not a message, that is instantaneously linked, maintaining the integrity of the universe's speed limit. Quantum computing represents a revolutionary leap forward, harnessing the power of entangled qubits. These quantum bits can exist in multiple states simultaneously, unlocking unimaginable computational power that far surpasses the capabilities of even the most advanced classical computers, promising to solve problems currently deemed intractable. Quantum cryptography leverages entangled photons to create intrinsically secure communication channels. The very act of an eavesdropper attempting to intercept the communication would instantly break the entanglement, alerting the legitimate parties and making truly secure, unhackable communication a reality. Future applications of entanglement extend to exciting, albeit speculative, possibilities. These include quantum teleportation of information, not matter, allowing for instantaneous data transfer, and the development of super-accurate sensors capable of detecting minute changes with unprecedented precision, revolutionizing fields from medicine to environmental monitoring. These speculative, yet incredibly exciting possibilities, born from the strange world of quantum entanglement, hold the potential to fundamentally revolutionize technology and profoundly impact our daily lives, ushering in an era of unprecedented innovation and scientific advancement across numerous sectors. Does the existence of entanglement suggest a deeper, more fundamental interconnected reality, where our conventional notions of separate, distinct objects are merely an incomplete and superficial understanding of the universe? This question challenges our very perception of individuality and existence. If profound connections can exist and exert influence beyond mere physical proximity, what does this truly mean for our deeply ingrained understanding of cause and effect? It forces us to reconsider the linear progression of events and contemplate a more holistic, interconnected web of influences. The perplexing measurement problem in quantum mechanics highlights how the very act of observation seems to instantaneously collapse entangled quantum states from a superposition of possibilities into a single, definite outcome. This suggests a profound link between observer and observed. This peculiar phenomenon subtly hints at a potentially profound and active role for consciousness in shaping the very reality we perceive around us. It raises the intriguing question of whether our minds are merely passive observers or active participants in the unfolding of the universe. If, at a fundamental quantum level, everything is indeed interconnected and part of a larger cosmic tapestry, does our individual identity truly exist as a separate entity? Or are we all integral components within a larger, entangled whole, sharing a common quantum destiny? The observer effect, a cornerstone of quantum mechanics, suggests that our conscious interaction with the world, even the simple act of looking, might be far more profound and influential than we have ever realized, actively participating in the creation of reality rather than merely witnessing it. Ultimately, quantum entanglement raises some of the most profound philosophical questions about the fundamental nature of our universe, its underlying structure, and our unique, perhaps even central, place within its intricate and mysterious workings. It invites us to ponder the deepest mysteries of existence. Take a moment to truly ponder these mind-bending ideas and allow your mind to freely explore the true, unfathomable depths of reality. The universe is far stranger and more wonderful than we can often imagine, and entanglement is a key to unlocking its secrets. If entanglement teaches one lesson, it is this: nothing important is isolated. Leadership, like quantum reality, is relational. Your decisions are threads in a tapestry. Use AI not as an oracle, but as a lens to reveal hidden lines. Strengthen EEQ so your team can co-regulate. Strengthen SSQ so your choices serve shared futures. Embed AIQ so your interventions are precise, testable, and scalable.